for me. We got to hear directly from the folks who are actually designing and building, deploying these climate robotic solutions, which really made everything so much more real and concrete. And so now we're going to spend the next couple hours in these 30-minute reporting back, and they're not meant to be a one-way, report back. They're really meant to also open up the discussion and to allow these different groups to also, share between each other what they learned. So first up, I'm going to invite our friends from the parallel session on aerial robotics to take the stage now, and I will hand the mic over to our wonderful co-moderators, Rinku and Jane, so that they can kick us off on the insights from their sessions, and then draw on their fellow panelists to chime in. The floor is yours. Thank you.
Thank you so much, Patrick. This was an incredibly fascinating and wonderful journey for me. This was my first time attending a conference of this nature. And hi, Jane. Happy to share some insights from our particular session. And I should preface by saying that I'm not an engineer. I'm not a robotics, person. My background is in ecological science and social science, specifically geography. And I do use satellite remote sensing, platforms in some of my own research. So I was very curious about the possibilities of, robotics, and much broader, of course, than just drones, which, many of my colleagues and myself also use some data streams from that. So it was a fascinating, session and experience. I just want to share some things about it and maybe echo something that Rob also mentioned in his overview comments as well, which is I was actually surprised by the level of attention to, kind of the broader system, the broader ecosystem, if you will, that the presenters really are very cognizant of and take into account. Whether it was, thinking about the role of robotics in the context of, drone-assisted planting of mangroves in hard to access or, difficult areas, and the use in that context of actually local knowledge and local collaboration was interesting and remarkable. And then, or other concerns as well in terms of, scaling and efficiencies, and really the paradigm shifts that, to borrow from another presenter's term, Elizabeth Hunter mentioned paradigm shift, and that indeed is something that characterizes this entire field, right? And this entire summit. It really is a game-changing community, and I think it's a community that is refreshingly open to thinking about the clients, stakeholders, end users, how we want to frame it, specific needs, and are obviously building into the design of the systems themselves those concerns and considerations. The question becomes, in my mind, one of, okay, thinking about what is the impact of that? How can we evaluate it, whether it's incremental change or a paradigm shift? What are systems in place that will allow us to really think across different kinds of interventions and really consider the broader implications for the ecosystems we're trying to assist, or the climate system, or indeed the people, right? The social part of the equation. So those are some broad comments. I'm going to invite my co-moderator Jane to chime in as well, and then we can loop back for some emergent kind of observations too.
Hello, everyone. Thank you, Rinku. Thank you, Patrick. Yes, yesterday it was really fun and fascinating to see them come together. I'm a PhD candidate currently working on my PhD, and I'm designing drones that not only fly but also walk on the ground, so multimodal drones. And so I'm quite interested in how maybe we can use these drones in the future. And talking to the speakers yesterday, applying them to drones that are like current drones applied to planting mangrove trees, to monitoring forest, or using gliders to data collect for weather, or creating flying wind turbines. It's just so amazing to see, or maintaining turbine blade repairs. I'm trying to see as a designer, how I can play a role in the future and in designing these things. And I love that the community was, despite having a lot of struggles, for example, passing waivers for their drones, and trying to have some paperwork on how to recognize their technologies, because this is very new and emergent. It seems to me that they have a lot of grit and that culture within the community to solve a common goal, to help solve the climate problems, which is a common goal, and using different aspects of it. So from micro or preservation to even maintaining renewable energy resources or infrastructures. It's quite interesting to see the broad range of application of aerial robotics that can be used in the future and towards the future. It was beautiful to see the technologists connect and the entrepreneurs as they have common struggles. And I love to see, like, one conversation that we had yesterday was I saw that another entrepreneur, Frank, for example, was trying to relate to Johan about his own struggles in his company. And this community is able to give each other support and expert advice on maybe what possible problems can you encounter and how to solve them. And I think collaboration and co-production are two key aspects in moving this forward. Also, exploration and experimentations as researchers and developers, right? This is a process of redesigning, the process of trying to making the system improve more and more, not just in the context of creating the technology itself, but also the policies or the systems governing them. So concerning the different stakeholders and also the different regulatory laws and processes that maybe the technology needs to go through to be able to be more accessible to people, to help more communities, because we want a larger scale in the end. We want as big a scale as we can, so that we can help more people. We can help the earth faster and better. In the end, we want these technologies to be developed, created, but also we want them to be safe and reliable, functional, and also very accessible in different communities through different partnerships. And this doesn't just involve technical knowledge, right? These are complex relationships, not just in technologists, but policymakers, users, communities, basically the local knowledge adding up in the redesigning process. And yeah, I have a lot of hopes in the coming years. Maybe we'll see how aerial robotics progresses in solving climate problems. And hopefully we can scale this as fast as we can.
I just wanted to add quickly, so that was fantastic summary, Jane. Thank you for that. And, kind of also, kind of an observation that I might make is this is a climate robotics summit. Of course, our interventions are presumably connected with a cross-cutting concern for climate change. However, what was also quite clear from the presentation, the presentations yesterday, was that these interventions really are overlapping with or kind of have implications for other domains beyond climate, right? So for example, land monitoring and land assets, or biodiversity loss, or pollution, and so on. So I think one of the very interesting questions or potential that emerges is sort of in this if you think about collaboration and co-production, as Jane, you point out, within the community as well, not just between the community and stakeholders, but amongst ourselves. I'm now sort of recruiting myself into your group. Like, what are the possibilities of really identifying where and when trade-offs exist between our interventions for, let's say, carbon sequestration and replanting, and potential side effects that might have in terms of biodiversity loss? There's actually not a direct and positive correlation between maximizing carbon and maximizing biodiversity, right? So there are trade-offs involved there in different streams of ecosystem services. And of course, these are, climate is a cross-cutting connection or concern across multiple domains. So I think one of the possible benefits of co-producing the science and tech itself is really reflecting on the different sorts of synergies and trade-offs in application areas and in potentially measurable outcomes, not just targeting one domain, but also implementing fast and efficient ways to assess side effects in other domains, right? So that's maybe something that would be really nice to see emerging out of a summit such as this. Like, what are some, can we mix and match particular sets of interventions for co-deployment to really target, intersections of climate implications with other concerns like biodiversity, pollution, and maybe even land access in the future. One can dream, right? So, but I'll just stop at that. Thank you again.
Thanks, Rinku. I think it's a very interesting point, and I remember one idea that was brought in the session yesterday, that hopefully we can have like a phase in the development process towards the commercialization, or towards making its scale bigger, when there is a phase where you have more leniency or less stringent rules to experiment and explore the technology itself. Because as what you're saying is, collaborating with different sectors involves for sure more paperworks, and you have to know that like communication between them is governed by existing rules and policies, and hopefully regulations or laws help build up the technology as being the technology more accessible, and also making it more reliable and safe to communities that need it the most.
Thank you very much, Jane and Rinku. That's really quality feedback and input. Would you want to invite, I don't know how many of the panelists in your session are here right now, but in case they are, you probably will recognize them more easily. And of course, continue please with the reporting back. That's been super interesting.
I see Mr. Johan, Miss Elizabeth, with me. If you want to pitch in right now as I read the names, Johan, you can start.
Yeah. So it was really cool to be able to talk yesterday. So basically, the two things I was super happy to discover is that there's two not large struggles, but concerns that we've had for the past months and years, that I was happy to learn that we're not the only one having, and which are shared, I believe, with a lot of people in that domain. The first one is that we're basically working with stuff that looks like drones, and today drone regulations are quite strict in a lot of countries, and also they are different between each countries. And one of the struggles is that sometimes a technological solution that uses something that looks like a drone allows to actually make something else safer or make something else cleaner, but is currently a lot limited by the fact that drone regulations are super strict. So maybe we need to find a way to all together share forces toward helping the community and helping climate robotics projects manage this aspect more easily by sharing knowledge and sharing contacts about civil aviation authorities in countries all around the world, to make sure that when there's a project which actually uses drones or stuff that looks like drones in a way that helps the planet, it's not limited by the regulation, but only by the technology. Make sure that we find a way to work with the regulatory people to open those applications. And the second point is that unfortunately, as of today in the world, a lot of people are using drones for, I would say, not super ethical applications, potentially hurting a lot of people. And we, on the opposite, try to use drones to help people and help the planet. But sometimes, because we are also on that part, we always put into question, are we actually using those drones and those robotics for a really cool application? Are we doing enough? Are we sure that we are actually helping? And when you are alone, it's quite easy to convince yourself that you're not doing enough, and that in the end you're just another sorry for the word, but another bullshit or shitty project. And by being able to communicate with all other people in the same domain, sharing the same problems, it's easier to actually recognize that what you are doing is the right thing to do, and keep the motivation. So I think there's a need for potential more collaboration between project on regulatory aspects and also on feedback to support ourselves toward using more robotics and more drones for cool, nice, helpful human activities versus less ethical and more harmful applications. That's what I remember from yesterday.
Thank you so much for that, Johan. Yes, definitely. Trying to mitigate the effects of the negative effects of climate change, right? Using technology as a forerunner for that. I'm seeing right now here Elizabeth Hunter from TreeSwift. Thank you, Johan, again.
Jane and Rinku, thank you so much for sharing that great overview. I really thought that you guys hit the nail on the head, and in your summary and what we shared yesterday together in the Aerial Robotics breakout room. I think one of the insights that I shared in terms of TreeSwift and applying our technology for land monitoring and measurements has really been the modular approach to our development. And so kind of taking a step back, thinking about what is the right technology or the right way to deploy the technology across the landscape that scales. So with these problems in climate robotics, or just climate and applying robotics to solve those problems, these are planetary problems that scale across thousands of acres, millions of acres, whether you're applying them to forests, to environmental sensing kind of in the atmosphere and the sky, across oceans. And so, TreeSwift started with putting our sensors on drones, and there are very there are areas where drones in forests are very applicable, such as forests that are dangerous to enter, affected by hurricanes or natural disasters that might just be inaccessible. But one of the things that we learned in the scaling of our technology is that, these are very unstructured, messy environments. And finding a solution or a way to deploy the technology across millions of acres is really what we're shooting for. And that led us to actually put our sensors onto a backpack-based system that's wearable by a person, which enabled us to actually partner with local communities, local workforce, who could actually take this technology and put it to work in a very easily and accessible manner. Whereas kind of scaling out in terms of our drones and our sensor on our drones, it requires very specialized skills and specialized workforce, various licenses, regulations. And so I think that there are environments where drones are very applicable, at least speaking with like forests, specifically, like I mentioned, kind of these dangerous, more inaccessible areas on the landscape. But kind of thinking about how that really scales across in a very kind of sustainable way and enables to partner with local workforce and rural communities is kind of how we approached the scaling of our technology in a really modular way, so that our sensors could be not only mounted on a drone, but put on a backpack that a person, an operator wears, or now even we're in our work with utilities, putting these on kind of ATVs and trucks as well. So I think that was one of kind of the insights, you know, from yesterday, is just about what kind of taking a step back, like how you really apply the technology to scale specifically.
Thank you so much for that, Elizabeth. Right. Scaling, and it seems like systems thinking and modularity to approach these scaling solution for climate. The next one that I see right now is maybe Max.
Yeah, hi, everybody.
Hello.
Yeah, also thanks to the summit and for Rinku and Jane for having us at the panel. Yeah, I actually don't have too much to add. So maybe focusing on the main thing that stood out to me was how there's definitely stuff that overlaps. Johan, you mentioned the regulatory part, that this can be a challenge for everybody, and that there definitely is a lot of learning that probably can happen within the space as well. But at the same time, we are working on very different technologies, trying to tackle very different problems. So there's, even if it's like clustered in aerial technologies or robotics, it's still a huge difference in what actually can be done with those systems. So that's kind of an interesting insight that came out for me.
Thank you so much, Max from Kitecraft. And last but not the least that I see in the list online right now is Miss Liliana from Invertebrate.
Yes, thank you very much, Jen, and thank you very much, Patrick, for inviting me to this Climate Robotics Summit. It was an honor for me, even though I don't have background on robotics, but I hope that what I shared yesterday somehow useful for the rest of the community. So probably from my side, I would probably talk more about the use of drone in terms of planting for a mangrove. So of course, I agree that embracing technology responsibly and leveraging its potential for the greater good will undoubtedly shape a brighter future for the humanity. But we also have to remember we do not need to create a so-called solution for a problem that doesn't even exist. So that's probably my point here. So the technology development should be based on the need of the, local voice. So we'll have to listen to the local voice more. And in terms of drone planting, only using the technology when necessary will be the best approach. The manual planting has more significant role as it creates job opportunity for the local people and therefore contribute more to the local economy. So drone planting can expand the effort of manual planting by facilitating access perhaps to remote and difficult to reach areas. And using drone monitoring perhaps will enable us to cover large areas in a short time with minimal disturbances, because it's flying high, and so you don't need to walk through the forest with masjid, for example. So in terms of the utility of drone monitoring, perhaps will be more useful for the community. And so the use, I will conclude here, the use of technology combined with local knowledge will be more powerful to better manage and tackle planetary crisis. I think that is from me. I will give it back to you. Thank you very much, everybody.
Thank you, Miss Liliana. Yeah, that's quite insightful. Using technology when, especially for people who need them the most, or the community's needs primarily. So the other panelist yesterday was Mr. Frank from Reblade. I'm not sure if I see him in the participants list, but yeah, thank you so much for everyone in the speakers. I see right now the question in the chat from Burke by Patrick. I want to read it right now. What were the main technical research questions and or challenges to commercialization in aerial robotics session? Yeah, I mean, main technical research question is a lot of these, I think for what I perceive from my side is that a lot of these emerging technologies, for example, the flying turbine by Max, is, although it has been conceptualized decades prior, right now the implementation in its implementation phase, I think there are a lot of more problems emerging as we continue to use it. Yes, Max, please.
Yeah, maybe to share directly on that, it may sound a little bit stupid, but it is somewhat like that. If you're building airborne systems, if something happens, you crash. And that, if you're high up, that can actually be pretty devastating. So in our development, if we build prototypes, that stuff just happens, so you crash. We have salvaged some of our prototypes. It was a low speed crash or low altitude, but if we crash in our operational envelope that we're normally doing, that can as well just crash the whole system is broken. So that obviously then you need to build up a system again. Takes a lot of time. So there's definitely, if you're on ground robotics, for example, it's still stuff can go wrong, but it may not necessarily be as devastating if you have something that's flying. So that's one of the bigger issues, which leads to longer development times, I'd say. So we try to mitigate as much as possible in the development. We have a whole software environment framework for basically the whole system. So we try to map everything and do hundreds of simulations simulations before we actually test the system then in the real world. That's one of the big issues for us, especially with a larger type of drone that also has to take safety into account and operate not too far from populations.
Thank you all. We can take maybe one last question. I know we started a little late. Do you want to take one question or?
I see one question in the chat. If anyone wants to speak out about a question, you can right now, or else I will read it right now. Okay, a particular question. One of the primary limitations of aerial robotics is operating time due to battery life. How do you address these in your solutions, and how do you see the limitation changing in the future? Automated battery or fully autonomous systems? Who wants to pitch in? Maybe either Johan or Elizabeth?
So we have a very specific system which actually only flies thanks to gravity. So basically it's a glider that ascends under a balloon. So basically what brings us up is gravity in a way, because Archimedes force comes from gravity. I mean, also from helium or hydrogen gas that we use in the balloon, but mainly from gravity. And then when we go down, we also use gravity. And in total, the flights last for 2 hours and 30. Actually, we did a test flight this morning, and the goal was to descend as fast as possible. So on this flight, we didn't make it last as long as possible. So basically, we spend a lot of time in the air without requiring battery for propulsion, without requiring battery for staying in the air. So I think this is one way of solving the issue of staying long in the air without big batteries. But then otherwise, I think there's been huge improvements in batteries density in terms of weight and volume in the past few years, which must improve the the value of the drones, basically how much time they can stay in the air on a given mission by quite a lot. And I think it will continue in the coming years, but I'm not an expert on that question.
Thank you very much, Johan. Thank you all.